Hi learners! On this video lesson, you will learn the properties of parallel lines. You will also learn the relationships between the angles formed when parallel transversals intersect parallel lines. With these learnings, you will gain a deep understanding of the importance of the application of these relationships in our daily life. All lines discussed here are assumed to be on one plane. Visual representations are shown, and real-life examples are cited to make the concepts relatable and meaningful. Strategies in analyzing and answering simple problems related to the topic are demonstrated to let you gain an understanding on how these are done so that you will be able to successfully answer geometry problems similar to these in the future. If your lesson is on parallel lines, rays and line segments, or if you have an assignment on this topic, or if you are preparing for a test in math, or a test in geometry in particular, or you are someone who is interested in learning math, then this video is for you. Having that said, please support the channel by giving a like, subscribe if you have not subscribed yet, and share this video. Thank you, it will definitely help this channel. Okay, so in an earlier video lesson, we saw that lines do intersect, and when they intersect, they do at a single point. But why do they intersect? Let us look at these learners. You might find the answer to that question here. We will measure the distance between these two lines. What did you see? You're correct. The distance between the lines is changing. It gets smaller and smaller until it becomes zero, and that is when the lines intersect. How about these two lines here? Will they intersect? Now let us measure the distance between the lines. What did you observe? The distance between the lines is changing. It is getting smaller, suggesting that the lines are getting closer. It means that somewhere away from here, the two lines will eventually intersect. So even if at this point they are not intersecting, somewhere away from that point, they will intersect because the distance between the two lines is changing. These are therefore intersecting lines, though we do not see their point of intersection. Now, let us look at these two lines. Let us check the distance between the lines. What did you observe? The distance between the two lines is not changing. It is constant. Will this line intersect? The lines will never intersect, for the distance between them is not changing. As we said, it is constant. We call these lines parallel lines. So, parallel lines are two or more lines on the plane which remain the same distance apart. We say that the lines are equidistant, meaning that the distance between them is the same all throughout. Hence, they will never intersect. And because they don't intersect, no angle is formed between them. When lines are parallel, we can put one on top the other and you will only see a single line. Parallel lines are marked with arrows like what we have here. Now, to show that lines are parallel, this notation or symbol resembling two vertical bars are used. Let us name the parallel lines and some points on the lines so we can write a mathematical statement about them. Because line A is parallel to line H, we can write this mathematical statement. This read as line A is parallel to line H. Remember that we can name a line using 2 points on the line. So for these same lines, we can write this statement instead of the first. We read this as line EF is parallel to line GH. Where do we see parallel lines in real life? Examples of parallel lines in real life can be seen in the blinds on windows, the lines painted on parking areas to guide parking cars, the way some crops are planted on farms, the equidistant wooden bars on your patio or porch, the posed on structures and buildings, and the trees on roadsides, to name a few. How about you learners? Can you name parallel lines in real life? I'm sure you can. Now, I want you to look at these, learners. What we have here is line X intersecting parallel lines A and H. We call line X a transversal. A transversal is any line intersecting any two or more lines. Here, the lines it intersects happen to be parallel lines. Let us have another transversal parallel to line X. Let us call this line Y. How many sets of parallel lines do you see now? You're correct. There are two sets of parallel lines here. Lines A and H are parallel as indicated by a single arrow on each line, whereas lines X and Y are parallel as shown by the presence of two arrows on each line. Different number of arrows are used to show which lines are parallel to which. Now, when set of parallel lines intersect each other as shown, angles are formed. Let us investigate these angles by first remembering what we said earlier, that when lines are parallel each other, one or two of these parallel lines can be put on top the other, and it would look as if there is just a single line there. Let's do that here. Let's go. What do you see now, learners? Okay, so we just see two intersecting lines. Because they are intersecting, vertical angles are formed. Now remember that vertical angles are congruent. Let us then mark these vertical angles with arcs. The number of arcs tells us which angles are congruent. By the way, how many lines are really there, learners? Okay, so there are two sets of parallel lines, and each set has two lines. So there are 4 lines all in all. Let us separate again these lines. We will name the angles for clarity. With this, I am sure that you can recognize pairs of vertical angles. Here are some: angles 1 and 6, angles 2 and 5, angles 9 and 14, and angles 11 and 16. Aside from the vertical angles, we also see that angles 1, 3, 6, 8, 9, 11, 14, and 16 have the same number of arcs on them, 2 arcs each, indicating that they are congruent. On the other hand, angles 2, 4, 5, 7, 10, 12, 13, and 15 have 1 arc on each, so these angles are congruent. This group of angles have special names given to them, but on this video lesson, we will just focus on knowing where they are located among sets of intersecting parallel lines and which angles are congruent to which. The classification of these types of angles is discussed on the video lesson entitled Angles Formed by Parallel Lines and Transversals. The link is down below. Let us have a closer look at the diagram that we have here. Recall that around a point of intersection, the measure of all angles formed add up to 360 degrees. So, if the measure of one angle is known, the measure of the other 3 angles can be determined. So, if angle 1 is 120 degrees, we can actually determine the measure of angle 6, angle 5, and angle 2. Here, angle 1 and angle 6 are vertical angles, so they are congruent. Since angle 1 is 120 degrees, then angle 6 is also 120 degrees. Now, angle 1 and angle 5 is a linear pair, which means that the angle measures add up to 180 degrees. So if angle 1 is 120 degrees, then angle 5 is 60 degrees. Look at the diagram, learners. angle 5 and angle 2 are vertical angles, so they are congruent. Therefore, angle 2 is 60 degrees. Okay, were you able to follow, learners? Now, let us look at the diagram as a whole. Using the arc as guide, we can now put the measures of the other angles on the diagram. Let's go. There you are. You can now see clearly which angles have the same measure and where these angles with respect to the lines are located. So, if these lines are parallel as shown in the diagram, then this set of angles must be congruent and therefore have the same measure. Likewise, this set of angles must be congruent and have the same measure. The converse is also true. That is, if this set of angles are congruent and this set of angles are congruent, then this set of lines must be parallel and this set of lines, the transversals, must be parallel as well. Here's the thing. The measure of the vertical angles formed when lines intersect vary. But the relationships between the angle measures and their positions with respect to the parallel lines and their transversals that are parallel remain the same. Now, when the lines become vertical, every angle measure becomes 90 degrees as shown. These concepts are very important to architects, carpenters, and construction engineers. Every time they design and construct furniture like racks and cabinets, or even just the stairs in the house, to designing and constructing large buildings and structures, balance and safety are their first concern. To ensure balance and safety, the top, the bottom, and every layer in the structure, regardless of the size, have to be parallel. This parallel arrangement is attained by making sure that the angles that need to be congruent must be congruent. With this, structures become stable. The probability to topple is remote. Okay, let us go ahead and answer the sample problem that follow. Here's the problem. Use the diagram below to answer the question. Which statement or statements is or are true? Option A, line A is parallel to line D. Option B, lines D, E, and F are parallel each other. Option C, the measures of angles 1, 4, 2, and 3 add up to 360 degrees. Option D, the measure of angle 1 is equal to the measure of angle 2. Option E, if the measure of angle 5 is 80 degrees, then the measure of angle 4 is also 80 degrees. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we're looking for. Okay, what are asked in the problem, learners? Here, we're asked to determine which of the option contains a statement that is true. What are given? We're given a diagram of intersecting parallel lines with some angle measures. To answer the question, we will examine its option and analyze the statement by identifying the key concept or concepts that relate to the statement. Then apply the concept or concepts in determining if the statement is true with the use of the diagram. We will begin with option A. It states that line A is parallel to line D. Is this true? Remember that lines are parallel if they do not intersect. Let us look at these lines in our diagram. Oh, the lines intersect. Therefore, the lines are not parallel. We move on to option B. Option B states that lines D, E, and F are parallel each other. Is the statement true? Let us look for these lines in our diagram. Here, we see the same number of arrows, 2 arrows on each line, indicating that they are parallel. Okay, so we move on to option C. Option C states that the measure of angles 1, 4, 2, and 3 add up to 360 degrees. Remember that around the point of intersection, vertical angles are formed and the measures of all the angles add up to 360 degrees. Let us consider the point of intersection between line A and line D and mark these angles with arcs. Let's go. So around this point, the measures of these 4 angles add up to 360 degrees. 2 of these angles have 2 arcs each, and 2 have 1 arc each. So a combination of these, wherever they are located on the diagram, would add up to 360 degrees. Can you follow, learners? Now, because parallel lines intersect another set of parallel lines, as in this case here, several of the angles formed are congruent. Let us mark all the angles with arcs to see which angles are congruent to which. Now, we will remove several arcs on the diagram except on those angles that are labeled. Take note that the angle measure of 360 degrees means a combination of 2 angles with 2 arcs each and 2 angles with 1 arc each. Look at the diagram, learners. Angle 1 has 2 arcs, angle 4 has 1 arc, angle 2 has 2 arcs, and angle 3 has 1 arc. So we have a combination of angles whose measures add up to 360 degrees. We now move on to option D. It states that the measure of angle 1 is equal to the measure of angle 2. Is this true? Let us look at this diagram again and locate where angle 1 and angle 2 are. What do you notice about angles 1 and 2? Okay, so angles 1 and 2 have the same number of arcs. Therefore, the 2 angles are congruent, so they must have the same measures. Let us move now to option E. Option E states that if the measure of angle 5 is 80 degrees, then the measure of angle 4 is also 80 degrees. Again, let us locate angle 5 and angle 4 in our diagram. Look at the angles, learners. They both have 1 arc. What does it mean? So it means that they are congruent, therefore they have the same measure. If angle 5 is 80 degrees, then angle 4 is also 80 degrees. So what are our answers, learners? Is it option A, option B, option C, option D, or option E? Okay, so the answers are option B, C, D, and E. There you are, learners. That was easy. I hope you acquired lots of learnings in today's video. Let us summarize what we have learned today. We have learned that, first, parallel lines are 2 or more lines on a plane which remain the same distance apart. Parallel lines alone do not form angles. Second, intersecting lines are 2 or more lines intersecting at a single point. 2 intersecting lines form vertical angles. Third, vertical angles are congruent. Fourth, linear pair has angle measures that add up to 180 degrees. Fifth, around the point of intersection, the measure of all the angles formed add up to 360 degrees. Sixth, a transversal is any line intersecting 2 or more lines. Seventh, the relationships between angles formed when parallel transversals intersect parallel lines are particularly useful in architecture, carpentry, and construction. Eighth, when solving a problem, you must read it and may read it several times when needed to know what you are looking for, to determine what are given, and to figure out how the given information helps find what you are looking for. Ninth, when the figure is given, make use of it and modify when needed. It is there to help you analyze and solve the problem. There you are, learners. Hope this video helps. That's it for now. If you have any questions, leave a comment below and don't forget to like, subscribe, and share this video to your peers so others will learn too. Bye.